So elliptical applications are actually a lot easier than a lot of the other problems with ellipses where you have to write the equation given the vertices and covertices and all that. This is a nice problem because you can center it at 0, 0, right? I can draw this xy coordinate plane like this and just say the center of the ellipse is at 0, 0. That makes this equation so much easier. It's going to look something like this. We've got x minus h squared over a squared plus y minus k squared over b squared equals 1. That's my standard equation for an ellipse. But the h and the k are zeros, so a lot gets knocked out right at the beginning. And if you look at this for a second, you can figure out what a and b are also from the picture. Right here, see that 14? That's the entire semi-minor axis from one covertex to the other. So we could say that is equal to 2. Let's see, this is going in the x direction, so that's going to be 2a equals 14. That means a equals 7. And this, the 19 value over here, that's going to be the entire semi-major axis. So from that, that just is b, like straight up. So it's pretty easy to write our equation now. It's just x squared over, what's a? 7? Okay, so x squared over 49 plus y squared over, what's b? 19. Okay, oh gosh, 19 squared. This is embarrassing. I know I should know. Is it 389 equals 19? No, it's not 389. It's going to be 361. There we go. 361 equals 1. Okay, so there we go. That's our equation in standard form, and this is what you would put right here. Now, the next part is to find the height of the arch. Let me switch colors so we keep track. Find the height of the arch, rounded, blah, 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 at a distance, and here's the important part, a distance of 5 feet from the base. I want you to keep your eye on that description and think about what that means. The base of the arch is where it touches the ground, okay? We're talking over here. So 5 feet from that base, that's pretty close to the center. We're actually only 2 feet from the center right here, okay? So this is going to be x equals 2 at that location. And they're saying, what's the height? In other words, what's the y value? So we just plug in 2 as our x value, divided by 49, plus, I don't know what y squared is, we're going to figure that out, divided by 361 equals 1. So if you solve this for y, and I'll go through the steps roughly, but I'm not going to go into great detail here. Right, we got 4 over 49 plus y squared over 361 equals 1. What we do is we say, great, y squared over 361 equals 1 minus 4 over 49. We multiply each side by 361, so we get y squared equals 361 times 1 minus 4 over 49. And you calculate that all out, you get something like this. Y equals, looks like 18.21 if I round it to 2 decimals. And here's the important part. Remember, if you're taking this exam with Slick, or any college algebra class for that matter, they often get a little particular about you saying feet. Because if you just say 18.21, they're going to say, well, do you mean inches or miles or what? What are we talking about here? So make sure you answer this in the proper units on your test.